My name is Josh. I work at Hortonworks, and I do a bunch of HBase development here. I apologize in advance for the slides. We're not really sure what's going on, so we'll be a little small. So I guess get your glasses out if you need them. So like I said, I work at Hortonworks. That's one of my primary roles. The other is I'm a member at the Apache Software Foundation, which means I do a lot of community development types of tasks as well. Over the past 5 to 10 years now, I've done a lot of work from SQL to NoSQL systems, primarily distributed in nature. Recently, I've started mentoring some of these new projects that are coming through the Apache Incubator as well. See the note here. Disclaimer here, when I'm referencing Apache projects throughout the presentation here, I'm probably not going to say Apache blah, 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 but just know that all these are products at the at the foundation, and they're a trademark of the foundation itself. So, okay, that was fun. So today we're going to be talking about democratizing HBase. So you probably wondering, like, Josh, what the heck do you mean by democratizing HBase, right? So obligatory, this is actually going to be a much higher level talk than I would normally give as an engineer. This is actually going to be much more focused on these sort of high level things that we might not think about as engineers when we're so much down in the weeds all the time. So when I'm referring to democratizing HBase, I'm really wanting to refer to how do we make our HBase installation, make this software work for the organizations that are using it? How do we go from just one sort of use case, and how do we expand that out to multiple different use cases? So real life, we have many different types of workloads, many different types of business that are all trying to use this system here. So as a distributed system, our goal should be, we should have one instance that can satisfy all these types of workloads that we want to run. So I won't lie to you that I'm not nearly smart enough to talk about the full gamut of what this really takes. So today what we're going to be focusing on are these two little slices in this sort of big pyramid. We're going to be focusing primarily on HBase and HDFS. There is way more above and below us that we aren't going to get into, from stuff like what happens if we're using containers in the lower level, abstracting away how our software actually runs. So stuff like Xen or KVM that's running below us. What happens if we have things like C groups that are limiting how fast our CPU can run? All this sort of stuff we're not even going to touch on. So as engineers on HBase, right? So we have a pretty developer-focused group here. I thought it would actually be a good idea to take a step back, right? So let's think about when a new group of people, say some company says, hey, we heard about this HBase thing. We think it's pretty cool, and we think we want to use it. We think it will solve these problems. How do we do this, right? So the first step would be you're going to do some sort of proof of concept. So you're going to have take some very specific problem. How do we sell apples to our customers? And you're going to say, okay, this is our problem. These are the things we're going to try to solve using HBase. Hopefully everything goes well. A couple months later, you say, hey, HBase actually did this. Great. So you start working this out to sort of a larger organization in the company here. Things continue to progress well, and eventually you'll get to some case where you have the one workload running on whatever the previous system was, as well as this new system, and hypothetically then, or hopefully, you can turn off the old system at some point. So this is sort of that like iterative cycle here. And eventually you get to this point where you start saying, okay, well, we did it once for this group over here. Now how do we go and do it for this other one? And you can follow the same sort of process here where you're going through these steps of taking previous business and flipping it over to a new system, but you start getting some new problems that arise as you have multiple groups of people starting to do this same process. So one of the things that you really have to start thinking about is when you're doing a proof of concept thing, you might be doing stuff on some hardware that you had laying around, or you might do a small buy, say like, oh, we're going to do 5 nodes to support this, and it's really more of a one-off sort of thing. But as you start to migrate multiple lines of business into one architecture, you start to wondering, it's like, uh-oh, this is like starting to be some real cost now, right? When we're talking about racks of nodes, suddenly we have to worry about things like how much are these nodes actually costing us? Where are we going to be hosting this hardware? Are we paying for power, space, and cooling? Does the data centers we have actually have enough quota to even let us put more hardware in there if we need it. So really the overarching goal here is we want to say, when we're running our HBase system, we want to be getting the peak performance we can get out of it. So we want to avoid what's happening on the left here, where we bought a bunch of hardware and we're only using it to 50% capacity. Because what this means now is we're paying more on the power, space, and cooling to host this hardware that we're not even using. So we want to avoid that, but we also want to avoid the far right side, where we're over provisioning our cluster. So we want to make sure that we're not actually slowing ourselves down because we're pushing too much load into the system. So we want to get right in the sweet spot there, so we're where we're actually utilizing the cluster, right at 100%. Ignore the fact that some literature like your Borgs like that, where you might actually be ideal to oversubscribe. For the purpose of this, we're just kind of expecting we want to get as close to full utilization of our hardware at any time. And that's really sort of the core of multi-tenancy here, right? We want to take all of our workloads and run them on this one hardware to the best of our ability that we have. So in the spectrum of multi-tenancy, we sort of have two sides here. One is this real-time, low latency stuff where we're dealing with operations in terms of nanoseconds and milliseconds, and we want to be very fast, very reliable. The system always has to be up, always has to be accepting new requests to multiple nines of availability, right? So this is things like you're handling website traffic. So you need to be able to get the data out of HBase as fast as you can and send it back to the client. The opposite side of the spectrum here is where you're dealing with these batch workloads where you don't care this millisecond type of thing. We're dealing more in minutes to hours to multiple hours. They tend to be much more scheduled, so you can sort of handle, you can defer them if you need to. You don't have to run them at a specific time. And we're sacrificing this latency to say, hey, I want to push that much more data through. So the goals of what we, to sort of satisfy all of these sorts of workloads across different things is we want to, we sort of break it down into these things here. So we want to have these multiple users on the system be unaware that everybody else is there. So if I'm running my job on the system, I shouldn't know that Mike is over there also running his job, right? I should be totally unaware of anything else happening on the system. I should just be able to go and use it to the extent that I am allowed to use it. To that point, sort of a follow-on there, I should have the ability to always have the ability to use a system, have my fair share of resources. So the fact of life here is that not everybody is as important as everybody else. Say I'm doing some sort of analytical, trying to answer some question for some new, we have some hypothesis and we want to look at our data and see, okay, well, is this actually working, right? I should have the ability to go and use the hardware to satisfy this question, but I shouldn't be able to interrupt somebody who's handling those really important, the revenue-driven question or requests that are coming in. So there's this prioritization here that with our system, we need to bucket it in such a way that we can apply rules to say the low important stuff can still run, but it's not going to preempt and keep the high important stuff from running. The final bit of this here is sort of the ability to provide some level of ignorance for our developers, right? We want to be very lazy. So we don't want to force the developers to have to write their code in such a way to use the system as we want them to use it. There should be something that's happening behind the scenes. Half of it is a point of we want to make the developer or let the developers be lazy so they can do what they want. But the other side of it is we want to make sure that they're not going to do something malicious and do something intentionally bad to sort of subvert us here. So obviously this leads me into my next point here where all of this sort of slicing and dicing of system resources is predicated on the fact that you need strong authentication to happen in the system. What good is it if I can take all of this, hypothetically, magically things that I haven't described yet? What if we can take them all, we can build this great system, but you have no guarantee that you're actually giving the time slicing to the person you thought you were? So all this sort of is driven on the fact that we, to build some sort of multi-tenant system with these limits in place, we need to actually have authentication in place so that we know that limits are going to the right person. So when we get into HBase itself, can start thinking about how we how users are interacting in the system, and the lowest level piece of this is at RPCs, right? So clients are issuing RPCs to the server, sending requests, servers do some computation and send a response back. So obviously the first place to sort of look at the system is how do we accept requests that are coming into the system. So quotas, RPC quotas are a great start to this. So these are essentially ways that administrators can set limits on the system based on a user submitting the request, so maybe request to a certain table or a request to a set of tables via a namespace. So these allow us to sort of start doing this prioritization to say, user Bob is only allowed to submit 100 requests per second. This certain table here is allowed to accept something like 10 megabytes of data in requests per minute. Or, say some namespace is allowed to send back 10 gigabytes of data per second, something like this. Per minute, maybe. That's a little aggressive. So this is really good for controlling a single user's access to the system. We can put these limits there in place that define how, sort of in an isolated system, how does this one user or a user accessing table respond? But how does that actually factor in when we have multiple users concurrently accessing the system? So RPC priorities are another thing that exists in HBase. It's a bit low level to the point that I think this is one of these areas that could use some more work. These are kind of driven by one of two ways. One is client side that can actually be submitted with the request itself. So things that how this happens now is when you go and access the HBase meta table, I believe the priority would actually be set higher on these RPCs because we know clients are it's very important that clients get the meta information when they need it, as opposed to, they can access their data table slower. The converse there is can actually be set on the server side. I believe Phoenix does this for doing secondary indexes, giving priority to secondary index updates as opposed to data table updates. But the converse, or the bad side of this, is that you actually have to write some custom code to do this. This isn't something that can say, I'm going to declaratively define some priorities to this certain table are higher than another. It requires custom code, so that's not the greatest. Another sort of type of resource allocation that we have in the system is space. So HBase is using the space in HDFS, and when we run out of space in HDFS, some really bad things can happen. And everyone who smiles, I know they know what I'm talking about here. Things go very badly when you run out of HDFS space, and you spend a lot of time having to recover that. So space quotas are my shameless plug for something that I've been working on lately. They are essentially a way that we can now define the amount of file system space that a table or group of tables in the namespace are allowed to consume. So this is another sort of level here that we can define how important you are. If you're putting a limit on some table for some hypothetical process that you're running, you can have a limit of 50 gigs and you can do whatever you want with that 50 gigs, but we can make sure that you're not going to consume so much space to not affect the other more important lines of business. Internal to HBase, there are a couple other things that are sort of happening behind the scenes that can have some sort of effect on how users are accessing the system. So as you're writing data into HBase, it goes to two places. It goes in memory, in the sorted in-memory store, and it gets appended to the write-ahead log. Eventually, we get enough data in the mem store, and we need to flush that to disk. And when that happens, we can't accept more writes until we finish that flush. So during this period of flushing here, it's sort of an intrinsic back pressure that's happening on clients. So the ability, the size of a flush and how long it takes you to do that flush is an intrinsic sort of back pressure pushing back on the clients to sort of limit how fast they can keep pushing more data if the system itself is taxed and unable to keep up. Compactions are another sort of way that this happens. Instead of, so we know we want to run compactions because they're optimizing the data on disk in such a way that's going to be improving our life as consumers. but we want to make sure that the compactions aren't causing these I/O storms. I think in literature today, you see a lot of people still really worried about compactions when probably from like years and years of, I read this really like scary email on a mailing list once, and it told me like, I really have to be worried about compactions. And it's like, well, yeah, you do, but we have lots of features now in HBase, such as throttling to make sure the compactions only run at a certain throughput. You have things like running major compactions in off-peak hours, lots of things here. So it's really important that we still want to run compactions, but there are ways that we can tune compactions in such a way that they are less impactful on these sort of things that are happening in the system. So another thing we can do to sort of help multiple users on using this single HBase instance is sort of in the realm of partitioning the physical resource that we have to run these queries. I don't want to make it sound here like I'm trying to like really poo-poo the feature here, but I think region server groups are one example of how we can physically partition our resources of HBase. But if you think about this in an abstract sense, this is really sort of an anti-pattern, right? If we think back to that original slide where we had those 3 blocks of bad, good, and oversubscribed utilization, if we're physically partitioning our workloads to only run on certain sets of the cluster, by definition, we're saying that if a cluster is idle, we're not going to be able to use all of the resources here. I don't want to say that it's a bad feature, and I don't want to, look a gift of a feature in the mouth here, but I think this is a sign that as a project, this is an area that we really need to focus on in HBase. It's a very effective hammer right now, but it's still a very heavy hammer. So I think this is more that we, as a project in HBase, we can do a lot more work here in the future to sort of, how do we think about on a live system, giving more priority, better prioritization to make sure that 2 workloads can safely and concurrently use the same physical resources without having this partitioning and essentially guaranteed to less effectively use this hardware that we're doing. Another sort of a thought process here is the same sort of problem where we've done things like separating yarn external systems from HBase nodes. So separating yarn from running on the same node that region servers are running, because someone will launch a massive MapReduce job and take down our cluster. Other things like Kafka or NiFi, who are moving lots of amounts of data, writing to disk. Again, these are sort of external systems that can be running on the same host that really affect our ability to actually use the system as we want to. So as we build these sorts of tools here, and we can sort of divvy up the resources that we're giving to all of our users of the system, we still have to go back and figure out or understand how the system is being used at a specific point in time. So with the hardware that we have, I really hope everyone actually has a system set up. If they're running some cluster, they should have some system set up to collect metrics. It was pretty awesome when Lars was talking earlier in the keynote, and he said, we have like billions, if not trillions, of metrics they're collecting. I kind of sat in the back and I went slack-jawed a little bit, but I'm like, wait, I shouldn't be so surprised about this. This is exactly what I'm going to tell everybody that they should be doing on their own today. So it's extremely important that we actually understand how our system is running. We should understand the theoretical limits of our system. Right? You can write to a hard drive at 100 megabytes per second. We can get about, tens of megabytes per second out of HDFS, and we'll probably get about 5 megabytes per second per node from a region server, right? But we need to understand these limitations and be able to quantify the user level workloads that we're running with what our system actually is capable of doing. The only way we can actually verify that this is actually happening is by collecting these metrics and doing this sort of quantitative analysis. The other bit here is that for the cases where a client is reporting that, hey, I'm using HBase, but I'm not seeing the level of throughput that I expect, it can sometimes also be an application level issue. So if a client is not using HBase properly, they're only writing to one region server instead of, say, 20, you will see a case where despite what you would do running the system, you may never actually see the performance if the client's doing something bad. You won't ever see the converse where a client can write more data through, right? That's why we have these limitations set on the server side to make sure that they cannot exceed our levels. So, the end of the day, when we're running some sort of system, when we're running HBase here, and we really want to support as many users as we can on this one system for the cost savings of it, we really need to understand what the needs of each application are. We need to understand what is the type of their usage patterns of the system, what are the, how much data do they actually need to provide, are they going to be sending to HBase, how much is going to be being read out, and how does this really affect the latency-wise, what kind of request guarantees do they have, or do we need to provide to them as a system? We need to understand what our system's ability actually is with respect to those problems that we're signing, or those SLAs that we're signing up to meet. So we need to make sure that we didn't buy a Civic and we're expecting a sports car. We need to make sure that we're actually have the ability to satisfy these SLAs that we signed up to meet. We can use these sort of throttling and partitioning tools that are provided by HBase as a means to provide these SLAs to the users. We need to make sure that when a user is important, their requests are treated with a priority, and when others are not, they're not treated with importance. I need to be cognizant of what else is running on our hardware. I think this is like by far and away the thing that makes me pull out my hair the most when I'm dealing with customers. I ask them what else is running on your system at this time, and I just feel this blank stare coming back at me. I'm like, you need to understand if there's slowness on your system here, and you don't know what else is running, how can we even start to understand where the problems in running this distributed system are? So having a very clear understanding of what software is running on each of our systems, or on each of our nodes, and how that is affecting our sort of HBase level and our users using HBase is extremely important. And the final bit is really understanding what our system is doing. The easiest way to do that is start collecting metrics. So understanding what is normal, comparing that to what is physically possible with the hardware that we're running, then being able to take that information and translate it in such a way that we can describe or sort of interpret it as how our users are accessing the system. So we need to understand, requests per second and ingress data into HBase. How does that relate to the user level workloads that are happening on our system? And then finally, when we identify some sort of problem, how do we take these metrics? How do we sort of quantify this into an actual change that we need to make to HBase to, again, meet our SLAs? And that's all.
Questions? Any hands?
Josh, when you were talking about kind of HDFS, HBase, the layers up to the app layer, can you talk a little bit about your experience or struggles or successes with taking applications from like a dev QA prod sort of methodology? Can you talk to that at all?
So I think the biggest problem that I run into is it really is like an infrastructure issue. Most recently, there was a case I was involved with where a customer was trying to onboard some existing workloads, some existing SQL-based workloads onto a HBase Phoenix architecture. And they said, hey, it works okay. And then we just have these massive pauses and HBase falls over. And we're like, okay, well, that sounds bad. Like, what can we do about this? And talking to them, and then suddenly we find, oh, they're running on a virtualized system. So a lot of the problems really come down to saying, well, we have some hardware in production that we know we want to use in the end, but we don't have anything to actually properly stage this to. So I say one big problem that definitely comes up, and I think it is a factor of cost and the ability to procure really usable dev, QA, and production environments. The groups that I've worked with who can sort of have invested in this as sort of a company. It's very much a mindset thing. The people who really understand how important this is, they tend to avoid this entire class of problems where you're saying, well, we can't really verify that this code we want to run in production actually runs on production because we have nothing reasonable to actually compare it to. I think the other thing that's I often see lacking is the ability is the proactive monitoring. People tend to really defer instrumenting their client as well as to understanding how to interpret server-side metrics until they get to production and it's sort of too late. So as much as you can sort of focus on right away, understanding how your client is working from your perspective, as well as understanding how the system responds to that client action are extremely important. And like you're really paying down that debt. Cool. Thank you, everyone.